Okay, now I think I'm live. I started the stream out of OBS and I hadn't started on YouTube because I didn't have the auto stream thing turned on. So, you probably haven't heard what I just said. The stream this week is going to be all about the tech, unlike last week's stream. But just before I get to that, I acknowledge the traditional owners of this land. I pay my respects to their elders past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream. Now, am I going to do that every single live stream? Maybe, maybe not. But for now, it seems like the right thing to do. So there has been a very interesting help thread going on the Discord about a scenario that seems to face a whole lot of people. Probably not as many of us as it would like. So the situation is, you're interested in home automation. You played around with a bunch of things for a while, and you've dreamed that one day you will have the chance to build a house or do a major renovation. And before I go any further, I'm just going to put something over this microphone that hopefully will reflect, that stop some of the audio reflections coming off these monitors. And you finally have the chance to put in place a whole lot of the things that you've been dreaming about, and you want to make sure that as you're doing the work on your house, you're not doing anything that's going to cause problems for you later, like while you're experimenting with automation. So what you want to do is have all of the infrastructure in place, the necessary wiring, and not make things harder for yourself. So this is a really interesting it's a really interesting question, because there are some challenges, particularly in relation to how you interact with the builder, assuming you're not doing the building yourself, and how you interact with the electrician that's going to be doing the wiring in your house. Once again, assuming you're not doing that yourself. If you are a licensed electrician who is also building your own house, then you're living the dream. So when the builder is going to be working to a very strict schedule, they will have stage payment requirements. There are going to be all sorts of things that are going to force them to work to a certain schedule. And if you want to mess around with things partway through, the builder is going to get upset. So you need to make sure that what you are doing is not going to get in the way of the builder. The electrician is possibly also going to have a very limited idea of the things that you're wanting to do, because they have wired up hundreds or thousands of houses. There is a very specific way they do it, and they follow their standard procedure. Like there is a standard way of looping the power around from light to light, bringing the active down to the light switch and back up to the light, and daisy chaining around to the next light. Anything outside of that is going to slow them down, and their objective is to get in and out of the job as fast as possible. So if you put specific requirements on them and say, I want my house wired up in a different way, they're going to go, whoa, 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 we've got to stop and talk about this. And the price will probably go up significantly if there's any deviation from the norm. So this is a long-winded intro to the problem of building a new house, doing a major renovation, and wanting to make sure that the cabling that you put in place is future-proofing yourself for whatever automation technology you might want to use in the future, while allowing the project to go ahead quickly and be usable immediately. That's really key. If you are doing a big renovation and you have all of the building done, and you've got the electrician to rough in the wiring, but you haven't finalized all of your devices and put all of your switches in place and light fittings and those sorts of things, you can't really use it yet. You can't live forever with builder's lights plugged into power points just in the corner of the room. You need to get functional lighting going as quickly as possible. So there are a couple of approaches to this. One approach is to treat the job as if you were doing a retrofit to an existing house. So you have a traditional wiring structure, you have a lighting circuit that serves multiple rooms, and the power daisy chains around each of the light fittings, and you bring the active down to the light switch and take it back up. That will allow the electrician to get in and out very quickly because they're not doing anything unusual, they're just wiring it up exactly as they expect. But it can be very limiting in the future. It's not allowing you to do a lot of interesting things. So ideally you want to go beyond that. Now if you do that, you have to follow the usual retrofit methods, like putting in, say, LifeX light globes so that you've got network control of the light globes. But then you have the same limitations of problems like having light switches on the wall that you're not allowed to use, because if you turn the light off at the wall, the globe turns off and then you can no longer control it with your phone or whatever other device. Excuse me a second. So if you're doing a building project or a major renovation, that's the time to really take advantage of the opportunity to put in wiring that is going to allow you to do more interesting things in the future, like centralized control and potentially dimming of all of your loads. And also keep in mind that what I'm talking about here is primarily lighting. That's the thing that most people are really concerned with in this situation. And there are other things as well, but we can talk about those later. So what you can do, all right, there were some fantastic suggestions on the Discord, and that has led to a couple of posts in the forum as well. So what I will do at this point is drop a link in. Let's see, this is a link to a post in the SuperHouse forum by user Aceblock42, who is James O, I think, on Discord. So two different handles but the same person, and it's a summary of suggestions of things that you can do to make sure that the wiring in your house is future-proof for whatever you want. And the suggestions go way beyond what I'm talking about with just lighting circuits, but I'm just going to talk about lighting circuits to start with. So if you have seen my home automation architecture video, you would know that the way my house is wired up is in a star topology. Instead of having power looping around each light fitting and then the active being brought down to a switch and then back up again, what I've got is cabling that goes from a central location. The simplest scenario, mine's more complicated than this, but imagine the simplest scenario is you have a switchboard where all of the power is available, and then every light in the house has a cable that goes from the switchboard all the way to the light fitting. And there is nothing else in between. There's no light switch, it's just a direct point-to-point wire. So you can imagine it being like a star. It goes from the switchboard out to every individual light fitting. And then the control of the lights is done from inside the switchboard. So if you haven't seen that video, I will drop a link to that as well. And that one explains this in a whole lot more detail that I won't go into right now. And here we go. So the challenge is trying to find some kind of a middle ground that allows you to have an immediately functional and usable house once the builder and the electrician finish, but allows you to retrospectively do whatever automation things you might want to do. And sorry, I'm just still getting myself sorted out here because I got distracted by Big Clive right before this chat started, I had the Big Clive live stream open, and then it got to about 2 minutes before my live stream was meant to start, and I was thinking, oh no, I've got to open everything, get it ready. So, so there were some great suggestions that, the best suggestions are the ones that in retrospect seem obvious, but you didn't think of them yourself, and that's definitely the case with this. There were some suggestions in Discord about how to set up wiring that will allow it to work functionally in a standard way to begin with, but then retrospectively you can add your own things. So what it looks like is, and I think this is really clever, the objective is to do the wiring in a star topology the same way that mine is currently done. But instead of taking the wire just from the switchboard to the light socket, like in my case, what you do is you take the wire to the location of the wall switch, and in the short term, install a regular wall switch. Like just put a normal traditional style switch on the wall, switching the active, and then you take the wire back to the light fitting. Now, there are a couple of important things to understand here. One is that in the traditional wiring method, active and neutral are taken to the light fitting, and then only active is looped down to the light switch and then back up again. What I'm talking about here is taking both active and neutral, and ideally earth, so you want like a twin and earth wire that goes from the switchboard to the light switch location, and then all of that goes to the actual light socket. Now, what this allows you to do is permanently connect power in the switchboard to that cable, and have a regular switch on the wall that allows you to turn the light on and off. And what you've got is a system that works from a user's point of view exactly the same way as a traditionally wired house. It's going to use more cable, because instead of jumping around from one light fitting to the next, each light fitting has to be wired all the way back to the switchboard. But for an electrician, this is not conceptually all that different to the way something is normally wired. It's just basically as if you've got a lighting circuit for each light individually instead of ganging a number of them together. So it's very easy to explain, and no electrician should have a problem with this. It's just, okay, we just wire one circuit to each light. Now, you don't need a circuit breaker for every light. That would be unnecessary extra expense. So in the switchboard, what you can do is gang a few of them together into one circuit breaker, the same way that you would have a lighting circuit for multiple rooms. Alright, so the question is, what has this gained you, and why would you do it? So in the short term, you have a system that works like a regular house. You can move in, you can live in it, all the light switches will work, the electrician will have done their job the way, or very close to the way they expect to have done it. It's not that much of a deviation from regular wiring, so everybody is happy, and you can live in your house. But what you can do now is, because each of the loads is brought back to the switchboard, you have a single central location from which you can control them. And that gives you a few options. Oh, and one other thing I should say. Make sure you wire twisted pair, like Cat5e or something like that, cable to each of the light switch locations as well. So where you have a light switch on the wall, you'll have active, neutral, and earth coming down. The switch will be wired into the active to make or break the connection, and then active, neutral, and earth will go out to the light fitting. Now, in a lot of cases, you need earth going to light fittings because they might have a metal body, so the body needs to be earthed. You'll see in a lot of houses, probably not so much now, I think because the regulations are tighter, but in the past it used to be really common for light fittings to only have an active and a neutral, and then for specific light fittings, like ones with a metal body, the electrician would just get like a single earth wire and loop it from somewhere handy and connect it up. But I think it's much more common now to have active, neutral, and earth to going all the way to every light fitting. So you can then either control power to the end load centrally from the switchboard in the same way that I've done it with the centralized start topology. In the future, what you could do, or you can control it at the location of the light switch. And because you have active and neutral at the switch location, it opens up a whole lot of possibilities for having powered control surfaces. You don't have to worry about problems like running no neutral power supplies and all sorts of dodgy things like that to make your control surfaces work. You've got active and neutral right there, so you can run a regular power supply for whatever smart switch you want to put in. And because you have Ethernet there, or twisted pair, which you can use for either Ethernet or just for switches like I do, you can also put a passive control surface there. What you can do is remove the light switch, which has been used to control the light, and just connect the active directly together. So effectively what you've done is remove the switch from the circuit and reverted the wiring to point to point, going from the switchboard to the end load, and there is nothing else in between. So what you still end up with is the wire that goes from the switchboard, comes down the wall to the switch location, then goes back up the wall and to the light, but there's no switch there effectively. It's just bridged through permanently. And then you can control the light from the central location using a dimmer module or a son-off or a DIN rail mounted relay or a contactor or whatever. So you then end up with a situation that is similar to mine, where you have centralized control, but you have the short-term functionality where it works as normal. So then at the light switch location, you have both Ethernet and power, so you can run either an active light switch or and use mains power, or you can run something off the end of the twisted pair and use Ethernet or switches. And I've been, over the last day or two, so since this suggestion came up in the Discord, and this is not, I should point out, this is not my idea. This is a result of several people on the Discord discussing this whole problem of what do you do if you're doing a building and you want to future-proof it. And Dodgy Brothers just said, where is our whiteboard explanation? Yeah, what I was actually wanting to do was connect up this overhead camera and draw some diagrams on the bench here, and it got to 2 minutes before live stream was meant to start and I hadn't connected up the device for this camera yet, so it's a bit late. All I'm doing is a whole lot of hand waving, but I think this is an important enough topic that it's definitely worth doing a whole video about this in the future. Like, not just a live stream of me rambling, but a proper edited video where I put more thought and preparation into this, and I have diagrams, and I think that would make a neat, it would make a really handy blueprint for people that are facing this situation. It'd be good to be, this sort of thing comes up all the time. I get people email me directly or contact me on Facebook or whatever all the time. Like every week I get multiple people saying, I'm working on a house, can you provide me advice? And I've got a number of things I can point people to, but I don't really have one thing as a starting point of, before you do anything else, look at this, make sure you understand it, and then everything else will flow on from there. And yeah, I think that's a video that's worth doing. But in the meantime, there is the post on the SuperHouse forum, which I linked to, by Acebook42, which is really, really good. It talks about this sort of thing, and also a whole bunch of other stuff. Oh, interesting. So point 7 on James's post is it said, having live and neutral inside the light switch gang box is code now as well in the US, so all new construction should have this. If not, request it. Yeah. So I'm not sure when that regulation came in here in Australia, but I haven't actually looked at it, but it used to be that a typical light switch would have only the active looped down and then going back up to the load. There'd be nothing else there. And so you see this problem all the time of people wanting to retrofit smart light switches like Sonoff Touch, and there's no neutral available, which means you can't run just a simple power supply. You need something like a no neutral power supply, and that complicates things. It limits the types of loads that you can switch, and it means you need an extra device, potentially with some loads, to allow power to pass around the load, and then you're wasting extra power. So ideally you want active and neutral at the light switch location. And as James said in this post, it looks like that is the regulation now in the US, and I'm pretty sure it is in Australia. So if you're doing a new build and your electrician is doing things properly, you should have active and neutral run to every light switch anyway. But historically, that's not the case. Most houses in Australia only have active at the light switch. Alright, I've been mostly ignoring the chat. Jesus just said, when does Z-Wave or Zigbee make sense against wiring? Alright, now that is opening up a big can of worms that I've done a whole video about, and it'll be somewhere around, maybe I'll find it. Okay, the time that makes sense is in a retrofit situation where you've got no other option. If you are building from scratch and you have the opportunity, or a major renovation or a major rewire, and you have the opportunity to hardwire connections, do the hardwired connections. Don't use wireless technology. Wireless is a fantastic solution when you're faced with a problem like walls that are inaccessible, or very high cost of recabling, or other things. And I'm just gonna see if I can find this other video. So there was a video called "Wires Not Wi-Fi for Home Automation." I think it might have even been a vlog, not a proper episode. Wi-Fi. I just realized that typing is probably extremely loud when you're, because my microphone is right near the keyboard. Probably sounded like an earthquake when I'm typing. So, let's see, this, I've got to get this link. I need to have some more links pre-canned. And I'm going to try to ignore all of the comments that I'm seeing, because to find my own article on my own video, I've just searched for it and found it on Reddit, and I'm going to avoid reading the Reddit comments and just go straight to the link. Alright, so this was my vlog rant a while ago about wires not Wi-Fi for home automation. And a lot of people, when they saw that video, thought that I was 100% anti-Wi-Fi, and that's not the case. This video was really a reaction to a whole lot of people who commented or who responded to my hardwired home automation system and said, why did you bother doing that? Like, hardwiring is stupid, just use Wi-Fi everywhere. Put in Wi-Fi light globes and Wi-Fi light switches, and don't worry about hardwiring anything. And I very strongly disagree with that point of view. My opinion is that if you can hardwire things, you should do it. It's better from a reliability, longevity point of view, from a security point of view, but wireless technologies definitely have their place. They're a really good solution if it's not feasible for whatever reason to do hardwiring. So if you've got an existing house, you might have old wiring that has only active brought down to the light switches. You don't really have the opportunity to do a major rewiring job. Then things like Z-Wave and Zigbee are a really good solution. And for other things like sensors, so what I try to do is I use hard wiring for services where if it fails, it's going to be a problem, like being able to turn lights on and off. I use wireless. I'm actually using a lot more Zigbee these days. I've got a little Zigbee device that I designed that is acting as the gateway between the Zigbee network and MQTT, and I'm going to do a video about that soon as well. But where is it? It's right here. No, the wire isn't long enough to bring it over in front of the camera. And so I do use things like Zigbee and Wi-Fi. I've got a lot of Sonoffs and other Wi-Fi devices, but I try to use those for situations where if it fails, it might be annoying, but it's not a huge deal. Things like temperature sensors, where I'm getting data from different places around the house, inside and out, and it can be useful to be tracking temperature, and that information can then be fed into other things like climate control. But if a temperature sensor fails or the wireless goes down for some reason, I'm not going to be crying in a corner. Whereas and also most other people in the house aren't even going to notice. Whereas if the lights stop working, everybody notices and I'm in the bad books. So that's the kind of the distinction that I make. Wire if you can, use wireless if you can't. They're both good solutions. Okay, I'm going to have a quick look at the chat and see what there is, because also I would really like to hear from other people, because this is a subject that I would like to cover more in the future, and I get all of my best ideas from other people. So if any of you want me to have a good idea to share in a video, please put it in the chat. Now, yeah. Oh, James said in the chat here, current standard is to bring live and neutral to the light switch. Yeah, just as he said in that post. And alright. NM says, hi from Chicago, deep dives are always welcome. Yeah, I need to do a few more. That's actually one of the reasons that I decided to do the air quality sensor thing as a bit of a mini-series. I kind of like the idea of doing mini-series videos, because if I try to do a fairly deep dive into a subject in one video, it ends up 40 minutes long, an hour long. I've done hour-plus videos in the past, and it still really doesn't go into it in enough detail. But it's a bit too daunting as a single thing. And so I kind of like the idea of breaking things down into a mini-series that will be on a topic like air quality sensors, showing the way I've done it so far is the basic version, the display version, then the software, and then part 4 is going to be the software side of it in terms of reporting, so charting using Grafana and all of that sort of stuff. And then part 5 is going to be the next version of the hardware, which integrates extra sensors. So that will make a little standalone mini-series talking about air quality sensors and how to build them. And overall, it's going to end up as an hour and a half or 2 hours of content, but it's not a single 2-hour video. It's little bite-sized chunks. And so one of the other mini-series that I'm going to do soon, probably the next one, given all the things that I've been working on recently, is the light switch mini-series. And I think this topic that I'm talking about now is really going to tie into that, because I've got the new hardware somewhere for the new light switch controller. I've got, yeah, I'm going to do a mini series about light switches, basically. Like make your own light switches, make your own light switch controller, how it's all wired together. And that's more on the input side. It's not so much the output side of how the lights are controlled by the automation system. It's how the automation system presents its user interface to you and allows you to send control signals. But I think that's a worthwhile little mini-series as well. And it will be more of a deep dive. Alrighty. David Watts just said, it's no wonder I got distracted by Big Clive. The guy is a nutter and a national treasure. Big Clive is cool. So, yeah, James said, Aussie wiring sounds weird. We run live, neutral, and earth to all the lights inside the Romex. Even the older light switches still had the same 3 wires, even though only line was present going to the light. Yeah, and that's a slight difference in terminology. I think in the US it's called line, in Australia it's called live, but it's the same thing. It's still L. It sounds almost the same when you say it quickly, line live. So now that is the case in Australia, yes. I think by the regulations say you have to run live, neutral, and earth to every light to the light fitting. And I think that has actually been the case for a long time. But what happened up until the most recent regulations was that the wiring to the switch was only the active being looped down to the switch and then back again. So at the light switch location, there has generally only been active, and that's the reason that companies like IT bring out devices like the Sonoff T4 EU1C, which is the no neutral touch switch, so that you can retrofit it into a place where a light switch only has active, it doesn't have neutral or live. And so, yeah, actually we call it active and neutral, or live. Standardization is fantastic. It's so good that everything is standardized all over the world. Oh yes, okay, Daryl has just pointed out something, well, a while ago, pointed out something in the chat, which I should have mentioned earlier. In this whole discussion about wiring up your house to allow flexibility for future home automation, there is one really big thing that a lot of people overlook, which is reversing the process. Now, because I didn't do it the way I'm explaining it now, my house is a problem. I have this star topology wiring. If I wanted to remove all of the home automation from my house, which I might want to do if I was selling the house, for example, then I'm faced with a problem, because to fit a regular light switch on the wall, what I would need to do is have the electrician loop the live from the back of the light fitting down to, I'll say active, because that's the terminology we use here. Switch the active down to the light fitting, to the light switch, and then back up to the light fitting. So it would revert it to something similar to an original, like just a stock wiring scheme. But the problem is that means you've got to do a whole lot of fishing to get cable through the wall, because the cable isn't there now. Right now, the wiring from my switchboard goes from the switchboard through the ceiling and directly to the back of the light socket. It doesn't go anywhere else. And fishing wire through walls is horrible, and it takes time, and the cost of your electrician's time is going to be far more than the cost of the cable. So that's really the critical factor. So if I did think ahead a little bit, because what I had in mind is, if this house is sold, I probably wouldn't sell it with my own home automation system in place. It would be uh, it would be really bad as a sales pitch, because people will come in and inspect the house and see a non-standard system and go, oh no, we're going to have to spend like 50 grand rewiring the house, and it would just put people off. So if I was going to sell it with an automation system in it, what I would do is pull out the DIN rail mounted relays that I currently have. So basically I would have the switchboard gutted and then put in something like Clipsal C-bus output controllers in the switchboard in the same place where the relays currently are, and wire all of the lights into those outputs. And I might end up ganging a few together, consolidate some lights. For example, in the office here, I've got 6 overhead lights, and they are wired up on 3 separate circuits. So I've got lights near the door, lights over here, and lights in the back part of the room are all on 3 separate control systems. So it's 3 relays in the switchboard. What I could do is just consolidate those all at the switchboard and have one output channel from a C-bus controller. But the thing is that people are used to C-bus. If you go into a house and you see a C-bus installation, you think, oh yeah, that's made by a big reputable company, you can find electricians that'll support it. You're not buying a problem that is like a one-off weirdo Frankenstein's monster setup like mine currently is. And people will feel much more comfortable about it, and it becomes not so much a negative about selling the house. It becomes arguably slightly a positive. You can say, well, the house is fully automated and it's got all of this Clipsal gear in it. Now, of course, that would cost me a fair bit of money, because I'd have to go out and buy all of the C-bus gear. I'd need to get it programmed by someone that is certified by Clipsal to do the work. But at least the wiring would all be there. I wouldn't need to change any of the wiring at all, because the topology is basically the same way. If you were wiring up a house from scratch using C-bus technology, the way my house is wired now is pretty much the way you would do it. The light switches are wired a little bit differently, because I've got Cat5 going, or Cat5e going to every light switch in a star topology. I don't have it looped around the way C-bus does it, using their pink twisted pair cable. But it's not that far off. You could rewire the light switches without too much trouble. You could run the C-bus cable to each of the light switches. That wouldn't be a huge hurdle. So my exit plan for this house would be leave everything in the house, gut the switchboards, and replace the contents with C-bus modules, and then there is a functional system that someone else can support. And I can walk away from the house, and the new owners can then call an electrician with C-bus experience, and it's not my problem. I don't have to support it. Everything is fine. But if I wanted to revert it to non-automated control, it really is a big challenge. It would be a lot of work to run the extra cabling from every light switch, every light socket down the wall to the light switch location, put a regular switch there, and revert it to just all manual control with no automation whatsoever. However, if I had been clever enough to wire my house the way Lusu and James and other people have been talking about on the Discord, rolling back the automation system would have been a hell of a lot easier. If the mains cable went from the switchboard to the light switch location and then out to the light switch, even if there is no light switch at that location while I'm using the automation system, it becomes trivial then to just pull out the automation switches, put a regular light switch in place, and you're done. Like for an electrician, it'd be literally 5 or 10 minutes per light switch. They don't have to get up inside the ceiling. They can just walk around the room, pull the automation switch off, cut the active, wire the light switch into it, screw it onto the wall, walk on to the next room. Like in the space of a couple of hours, you could go from a fully automated system to reverting to a totally manual system with no automation dependency whatsoever. And then back at the switchboard end, just group together all of the wires that go out in that star topology and run them into circuit breakers for lighting circuits. Just group however many are appropriate into each circuit. So I wasn't quite clever enough when we did this major rewire. I should have thought ahead and done what was suggested here and run the cable down to the light switches. Okay, so Patrick pointed out to install power in Cat5 is not a good idea regarding AC pickup and space. Alright, so this raises a couple of interesting things. There are regulations, and for a very good reason, that require a certain level of isolation between Ethernet and mains wiring. And there are regulations such as requiring the cables to cross at right angles. You definitely shouldn't have a mains cable and an Ethernet cable lying side by side running parallel for any particular length, because what you'll get is inductive coupling between the mains cable and the twisted pair. Even though twisted pair is designed to reject noise, that's actually the reason for the twist. It's because any electromagnetic field that is applied to the outside of it will be applied equally to the two wires in the pair, and because the wires twist, you end up with a 180-degree reversal of the phase, and then the noise cancels itself out. That's kind of a hand-wavy explanation, but basically the reason those wires are twisted is so that the induced voltage across them is they're opposite and they cancel. But that then raises the issue of what do you do at a light switch location where you want to run power down to the light switch, but you also want to run twisted pair to it. And that is one of the reasons that, so it's not just for electrical noise. One of the other issues is insulation. Now, if you've got two wires that are in physical contact with each other, and one of them is a mains wire, so it's got, say, 240 volts AC in it, and the insulation on that wire, I can't actually remember the spec, I think it might be, is it 600 volts? I don't know, but the insulation on the wire is required to be able to withstand a certain voltage to isolate the contents of the wire from anything on the outside of it. So if you have a mains cable and you grab the outside of that wire while it's live, obviously the insulation has to be strong enough that you can't get a shock from it. It's protecting you from the voltage that's inside it. And if you have a mains cable and an extra low voltage cable that are in close proximity to each other, then and you have some kind of abrasion or damage to the insulation, basically what you have to do is, I think the reasoning behind the way the regulations are written is you have to assume that your cable is going to be exposed to a voltage that is not protected in any way. So if you had a low voltage cable, an extra low voltage cable like a switch wire or an Ethernet cable, and it's in physical contact with a mains cable, imagine the mains cable had no insulation. It was just bare mains on the outside of the Ethernet cable. The Ethernet cable itself only has to carry a very low voltage because Ethernet runs at only a few volts. But the voltage that is being applied to the outside of the insulation could be 240 volts. So if you are wiring, mains wiring and data cabling, so even if they're crossing at right angles, if they are physically against each other, then both the cables have to have insulation that is rated to the highest standard of the two cables. So that means that what you need is Ethernet cable that is rated to mains voltages. And so my limited understanding of this is just from what I've gathered over the years. One of the reasons that CBus uses that pink twisted pair cable is, well, one of the reasons is so they can charge 10 times as much for it, and you can't just go out and buy regular Ethernet cable. But one of the reasons is that the insulation on that cable is certified for mains voltages, and that allows it to go inside a switchboard alongside mains cable, and it allows it to exist physically in the same location without physical separation from mains cable. So normally with mains cable, if you've got mains cable in a wall and you've got Ethernet in a wall, they need to be physically separated. So there needs to be either, I think the regulations say, a certain distance or a physical barrier between them. So for example, if you have a stud in your house, like what I'm talking about is a vertical piece of wood, a timber within the frame, and you have mains in the cavity on one side and you have Ethernet in the cavity on the other side, that timber will provide a physical barrier between the two cables, so that's okay from a physical separation point of view. But if they're in the same cavity, they need to be a certain distance apart. Part of the reason for that as well is allowing for things going wrong in future, like someone hammering a nail into a wall and skewering through a mains cable and an Ethernet cable at the same time, and then exposing the Ethernet cable to mains voltage. And then all of a sudden, all the devices that you've got plugged in on Ethernet, boom, you've got 240 volts on them, potentially, and then you're having a really bad day. So there are reasons for these regulations. They're not there just to make our lives hard. They're there to keep us safe and to cover scenarios that we haven't necessarily thought about, but someone has thought long and hard about them. Some regulations just seem like they are there, though, to make life hard. So that actually expands a little on what I was suggesting earlier. Okay, if I was doing this now from scratch, I would run the mains cable, loop it to the switch location, and then take it onto the load. And I think what I would do is I would pay the price gouge price to install CBus cable to each switch location, because that allows you to use it in like a DIY home automation system, like the way I'm doing it, just with buttons on the end of the wire. Or you can retrofit a CBus light switch, like a Saturn style switch or something, one of those cool looking light switches, and it's going to work. And you know that the certification is there that allows that cable to be physically in the same location as the mains cable, because it's specifically approved for that purpose. And that way you're not going to have insurance issues or electrical inspection issues or anything like that. Any electrician or inspector would come in and look at it and see mains rated cable, we've got the CBus cable, it's fine, it's in the same location, but it's specified for that purpose, so it's all good. Okay, so all right. Oh, this is nice. Al commented Sydney, so that's in Australia, about 1,000 kilometres north of here. The house is less than 2 years old and it has live, neutral and earth at each switch feeding up to the light socket. Has made adding on-off minis very easy. Yes, that is really cool. And that's the way it should be. So I really like these new regulations that say you've got to have live, neutral and earth at the switch. It makes retrofitting so much better. Now, where I just skipped in the chat and missed something. Okay, so Aaron asked, What's your ideas about the ring main? How can we make all our individual sockets switchable? Obviously, the lighting circuit solution would seem to be extreme for a ring main. That that is a whole other problem. I've briefly thought about that in the past a couple of times and run away screaming. So just to explain what Aaron is referring to here, so far I've just been talking about lights. Lights are a relatively low power load, and there are usually a reasonably small number of them. Like you'll have typically one light switch or two light switches perhaps in a room. You'll have one or a couple of lights in a room, and the power that is taken by lights is fairly low, so we're not dealing with switching large currents most of the time. But for the ring main, what that's talking about is things like GPOs or power points, and in a room you might have 2 or 3 or 4 or 5 power points, or in the case of in the case of my lab here, 72 power points, and they have to allow for higher current devices. You might plug in a space heater, which is 2.4 kilowatts, so 240 volts, 10 amps, and you might have multiple things plugged into different sockets around the room. So the cabling is physically larger, which makes it more expensive per meter. There are more of them, and they are distributed around the walls instead of inside the ceiling, which makes it harder from an access point of view. With light switches and light fittings, you can, it's not, depending on the way your house is set up and your ceiling space and everything, it can be annoying to have to modify the wiring, but it's not too bad because most of the time it's coming down vertically. It's not traveling horizontally through walls. Power points are a different thing. The wiring for those normally loops around from one power point to the next. It goes horizontally through holes in the studs around the wall, which means if you want to add more, getting the cable through can be a nightmare. You can be forced to do something like run the cable down under the house, bring it along and then back up again, which may not be possible if you're on a slab, or maybe you have to bring it down from the ceiling all the way down, which means going through a noggin, which is a horizontal strengthener in the wall, and that can be a problem. Or you might have to cut plaster to run the horizontal cabling and then patch up the plaster. So modifying wiring to power points is harder than modifying wiring to lights. It's higher current, the cable is thicker and heavier, there are more of them, and ideally what we really want to have is control of individual power outlets from the home automation system in the same way that we have control over lighting. And so one of the things I really like using are the Sonoff S56 units, I think they are, which are the the smart power sockets. It's just an external device. You plug it into a power point and then you can control it using Wi-Fi. I've got a few of them plugged in around here. That's how I use She Who Shall Not Be Named to do things like turn on and off the monitors in my office, and the soldering iron, the exhaust fan, the light in the 3D printer you can see over there, the power for the printer itself, the power for the printer in my other room. They're all controlled using S56s, but ideally that control should be built into the GPO. It should be possible to plug a device into a power point on the wall, have local control because you want to be able to flick the switch on and off, but also be able to control it through your home automation system. Okay, I don't have a solution to that one. As Aaron has pointed out, doing a loop doing a star topology, the same way that I'm suggesting to do the lights, you could do it. What you could do is have every power point in your house wired back directly to a switchboard, control it from the switchboard. but that would be a total pain. It would be so much cable. It would add so much in terms of the switching infrastructure at the switchboard as well, because instead of having, like say in a typical house, you might have 10 or 15 different outputs that you want to control the lights in the different rooms. All of a sudden you'll have 30 or 40 or 50 outlets that you want to control, because you've got a few outlets in every room, and it's just a pain. So I don't know a great solution to this, and I think this is a situation where the balance tips in favor of putting the smarts at the outlet instead of putting it centrally. Now that then really highlights the whole communications problem, and it brings us back to a situation similar to if you were retrofitting lights into a house that already has traditional wiring and you don't have neutral light switches and all of those sorts of problems. So in my own house right now, my power points are wired in the traditional way. It's multiple power circuits. In fact, because I've got so many GPOs here in the lab, I've got 3 power circuits dedicated just to this room. Normally what you'll have is a couple of power circuits for an entire house. You might have a couple of rooms worth of power points wired on one circuit, and then you've got one circuit for each. A couple of rooms you'll have a power circuit for high load appliances like a clothes dryer and that sort of stuff, electric oven if you've got one. So where was I going with this? This is a situation where I think what we need is power points with the smarts built into them, so that you can control it locally and you can control it from the home automation system. Now, one of the things that slightly differentiates power points from lights and tips me over in favor of doing it this way is that the point of the load and the point at which you control it are in the same place. With a lighting circuit, what you've got is power going to a switch, which is in one location, and that switch is controlling something that is in a physically totally different location. Whereas with a power point, the switch is right there. You've got the socket on the wall, you've got the switch in the same physical structure. So separating the control circuit from the input side, like the user interface side, is not such an issue. With lights and the way my house is wired, my light switches have absolutely nothing to do with the lights. Electrically, they're totally separate. They're just low voltage controls. When you interact with a light switch, what you're doing is sending a command to the home automation system. The home automation system understands that you're sending it a command, and it then acts on your behalf to turn the light on or off. Whereas with control over power points, it's much more of a direct thing. And the other thing is that normally with power points you will leave them on, typically. It's not something where, for me, I would like to be able to control power points from the automation system, but the scenarios where you have something plugged in and you want to turn the power on and off regularly is a subset of all the devices that are plugged into power points. With lights, you want to turn them on and off every day, whereas with most things that you plug into a power point, you don't turn the power point off and on every day. You might control it at the device, but typically once you've got something plugged into the power point, you turn the power point on and you leave it, and then you control the device from the device itself, whatever it is that you got plugged in, which could be, like a TV or something like that. Now, apart from phantom power issues where the TV is always drawing power, the usual situation is you want to turn the TV on, or you plug the TV into power, you leave the power on, and you control the TV's behavior from the TV. You don't control it from the power point. And in the situations where there are exceptions, that's where I use things like the Sonoff S56. I think it's 56, I can't remember. I think that's the model. I really should remember, I should know all the Sonoff models. So that was a long rambly response to Aaron. I'll try to summarize it. PowerPoints don't have the same switching needs as lights. In most situations, you plug devices into PowerPoints and turn them on and leave them on. There are some situations where you do want to be able to control a load connected to a PowerPoint and turn it on or off through your home automation system. In the short term, my solution to that is using externally controllable devices like S56 devices plugged into a regular PowerPoint. In the longer term, what I would like is PowerPoints that are like a Sonoff in a PowerPoint as a single unit. And yes, I know they're available. There are plenty of them around. Certification once again becomes an issue, but you can buy certified Tasmota compatible smart PowerPoints in an Australian standard. They're like 50 or 60 bucks per PowerPoint, but you can buy them. And they actually kind of look cool and they work. So I think that is the scenario. All right, so communications. I think doing the loop around wiring to GPOs is fine, and relying on wireless control, and I'm speaking from my own personal opinion here, other people might have different opinions. I actually wouldn't have a problem with using PowerPoints that use Wi-Fi or Zigbee or whatever wireless communications method to control them, as long as they also work in offline mode by directly pressing the button on them. And what that means is that the worst case scenario is, well, not quite the worst case, but a bad case scenario is your wireless network fails, your home automation system is dead, and you've got no way of controlling anything through the automation system, but you still have power. Your power outlets will still work because you can control them directly. The button or the switch that's on them controls the internal controller, sends a command to the internal controller and turns them on or off. And if my automation system died, and the worst case scenario was that my PowerPoints behaved exactly like regular automated PowerPoints, that's fine by me. As long as I can still walk up to one of the PowerPoints, press a button, and it turns on power. I think that's good enough. Now, I said it wasn't the worst case scenario, it's just a bad case scenario. That's because I see the worst case scenario as something more like the WPA encryption is compromised and there's someone sitting outside my house and they get into my Wi-Fi and take control over devices in my house. I mean, that's not such a good thing. So, putting security issues aside, I think that a self-contained smart power outlet with Wi-Fi I think that's a perfectly good compromise. And I've been looking at those devices for a while now, watching the different types become available. I've never actually installed one. I've always gone for like centrally switched. For lighting, I haven't really, or for retrofit, I've just used the S56s. Talking this through now, you're seeing my brain process this in real time. I'm becoming more and more interested in the idea of using these smart PowerPoints, and I think I might order a few and experiment with them, just see how good they are, and whether it's worth retrofitting those into a few places in the house, like places where a lamp might be plugged in, anywhere that there is a load that it would be useful to be able to control it from the home automation system. Now, one other thing this brings up is power monitoring. Now, one of the really useful things would be a smart GPO with Wi-Fi control and power monitoring, so that it can report, just like the Sonoff Power, how much the load is pulling. That can be quite useful information. If the smart power point could give you that information, that would be a really useful thing as well, because then you can measure power not just like on a whole house level or a per circuit level, but on a per device level. You know how much power your coffee maker is taking, or your washing machine, or whatever. So at the moment what I've got is a Sonoff Power controlling the power to the washing machine, and so it can monitor how much power it's taking, which means that the home automation system can figure out when the washing cycle has finished, and it can send a notification. At the moment I don't actually have it sending notifications, but it is tracking all of the power, and also of the clothes dryer. So I can, I've got charts being recorded where it's plotting the power usage of those devices, and you can see very distinct periods where the washing machine is running, and then here it gets to the end of the cycle. So adding some kind of behavior based on that is trivial. Like when you see power has gone from a certain level to below a certain threshold, you know it's done its job. So being able to monitor power is useful. Things like, even something silly like a kettle. You can start a kettle remotely. It boils. When it finishes boiling, it turns off. The power requirement drops, and the home automation system can say your kettle is boiled. I mean, I'm just searching for it's like I've got a solution searching for a problem here, but still, being able to monitor and measure things, I think, is vital. There's a very clever guy named Andrew at the local hackerspace, and he has a saying which is, if you don't measure, you don't know. Basically, don't trust things. If something says that it's a certain dimension, don't trust it, measure it. Or if something says that it is behaving in a certain way, don't trust it, measure it. If you don't measure, you don't know. So being able to measure the power usage on all of the power points around a house, I think would be really cool. Is there any more I want to say about that? I don't know. Okay. Oh, one advantage of this is that you have the whole rollback benefit. If you wire your house up with the regular power ring that goes around to all the GPOs, and you put smart power points on, once again, if you want to sell your house and roll it back to regular power points so that you don't freak out potential buyers of your house, it's easy for an electrician. You just take it off the wall, unscrew the smart power point, put a regular power point in place, stick it back on the wall. 5 minutes per GPO. Someone could go around your house, de-automate it in a couple of hours, give you a certificate of safety, of whatever the thing is, the certificate of electrical safety. Everybody's happy. So I don't think wiring individual GPOs back to a central point is worth it. I think that is something where we take the smarts and move it out to the edge instead of trying to keep it centralized. All right. Oh, Frank McCullidden, I'm sorry. I'm not speaking very well today. Frank said that a ring main circuit is not allowed in Oz. Perhaps I'm misunderstanding the terminology. What I thought Aaron was talking about was just looping a main circuit around from one GPO to the next, and that is definitely standard in Australia. But if that is not what is meant by ring main circuit, then that's a term that I haven't come across before. All right. Okay. So, Stephen asked, what do I think of using Shelly and the Sonoff Mini and placing them next to the light in the roof, then you can still use Switch? Yeah, well, that's great. That is definitely a good solution to a retrofit scenario, and that's really good if you are coming into existing wiring and you want to be able to control end devices. Then something like a Shelly or a Sonoff wired at the point of the load is fine. What that does though is give you a reliance on your Wi-Fi working for your lights to work, and so many people might react to that and think, oh yeah, but like Wi-Fi always works. The reality is it doesn't. A lot of home Wi-Fi systems are kind of dodgy. If you're serious about setting up home automation, then it's definitely worth putting some effort into setting up a good Wi-Fi network. In my house, I'm running Unify gear, so I've got Ubiquity. I've got Ubiquity access points. Sorry, I'm saying that the wrong way around. As you can see, my brain is not really on the job today. I have a couple of access points. I've got Unify managed Ethernet switches in 2 of my racks. I've also got some unmanaged switches, but my core switch and then 2 of my edge switches are Unify managed Ethernet switches, and I'm running PoE out to Unify access points, 1 at each end of the house essentially, and I showed that in a previous video as well. I've got to say that since switching to that, Wi-Fi has worked brilliantly. I've got great coverage everywhere, it's reliable, it's fast, that really hasn't been a problem. But still, even if you have Wi-Fi devices like access points that are 100% perfect, there isn't a single bug in the code, the technology is fine, the hardware is robust and it never fails, you know, the hypothetical perfect situation, that's still not good enough because it's built on protocols that themselves are constantly evolving. If you think back to Wi-Fi from a few years ago, so in terms of authentication, we went through WEP, there was WPA, WPA2, like the protocols keep evolving, and you look back at protocols as they were a few years ago, they're totally broken, they're cracked. Like if anyone is running, you know, WPA on authentication on their Wi-Fi, you might as well not even have anything because it's so easy to break. And right now we think our current networks are great, they're secure, people can't break into them. A few years down the track, we're going to be a few more generations along in the software, there are going to be more vulnerabilities that have been discovered, and what we now think of as being a rock solid system is going to be considered to be rubbish. So cracking the security on a piece of wire is difficult. And it's still going to work 20 years from now. Cracking the security on a wireless signal might be hard now, it might not be hard in 5 years or 1 year or 10 years or whatever, it doesn't matter. At some point in the future, that Wi-Fi is going to become a problem. So that's why I don't like to rely on Wi-Fi for essential systems within the house. So in response to that question about what about just using a Sonoff Mini or a Shelly, yeah, that's fantastic within certain limitations, and it certainly allows you to do things that you couldn't do with older houses and problems with rewiring and retrofitting and all of those sorts of things. Okay. Oh yeah, so Aaron said, in response to Stephen, I designed a ceiling rose replacement with a Sonoff Mini built-in that allowed you to use the existing lighting the existing switching circuit. Yeah, that's cool. Nice work, Aaron. Yeah, and the nice thing about the Sonoff Mini and the Shelly is that you can use the existing light switch as the control input to the device, which means that for people within the house, everything behaves as they expect. Light switches control the lights, and it can work without relying on the Wi-Fi. So if your Wi-Fi fails, you can still control the lights because the switch on the wall is directly interacting with the Mini or the Shelly and giving it control signals. So that's a nice fallback sort of situation. All right. Let's see. What else do we have to see? So Dodgy said, oh, and also I haven't watched it yet, but Dodgy has just posted a new video about his ongoing project to build a new control cabinet for his CNC machine, which is really cool, and it makes me so jealous of his welding skills. So go and check that out. I saw it was posted, but I hadn't had time to watch it before this video, so I'm going to check that out. So Dodgy said, in Discord I suggested pulling the wire back out of the wall when you wanted to go home automation. To save cost, you could leave the wire in the wall and just rehook up the active. Yes, exactly. I would leave the wire in the wall, and I would do that also for the rollback opportunity, because if you ever want to undo your work, having that wire in that wall will save you so much grief later. If you can just take the light switch off, put a regular light switch back on, put it into the active, then awesome. Yeah, so Andy, hey, Andy Yelmy is on the chat. He says, Clipsal CBus pink cable is just pink Cat5 with their own electrical and software protocol rather than Ethernet. Yeah, I think it is actually very similar to RS485. It's a multi-drop serial protocol, and there has been some reverse engineering work done on that actually many years ago. That protocol was cracked by a guy in Adelaide, and I won't look up the information for that right now because I would be going off chasing a squirrel, but yes, so Andy's correct. The pink Cat5 cable, the CBus pink cable is Cat5, and the real advantage to it, as I mentioned earlier, is the certification. The fact that you can put that cable into a place where there is mains wiring, and the insulation on it. I mean, I don't even know if it's any different to regular insulation. It might be, for all I know, exactly the same as regular Ethernet cable, but it's the certification that matters. The fact that Clipsal have paid to have the lab tests done, they've had the certificate issued, and you can take their pink twisted pair cable and deploy it inside a switchboard with mains voltages all around it. That is the key. You can use it for Ethernet or whatever else you might want to use. It's just Cat5, as Andy said, so you can put switches on the end of it, as I do. Well, I do with regular cable, not with the CBus cable, but it avoids all of these problems that you're likely to have with trying to put regular Ethernet cable in the same space as mains wiring. All right, so let me see. Looks like there's been some weird stuff going on in the chat. I'm way behind on the chat, so far behind on the chat. And let me see. I'm not even sure if I've gone back far enough. Oh, there we go. Okay. So, this is a really good statement. James O'Gorman said, "A lot of people and equipment has been lost in creating these standards." Yeah, I think what James, because I'm so far behind on the chat, I think what James is talking about there is what I was talking about maybe half an hour ago, where I said that there is a reason for these standards. Yeah, I don't know. There's a saying about it. I can't remember what it is, but basically, it's like every standard has been paid for with a life. Um, the most of the time, regulations are there for a reason. It's because there's been some incident, something has happened, some equipment got destroyed, someone got electrocuted, something went wrong, some house burnt down, and there was an investigation, and people try to figure out what happened and then try to prevent it from happening again. So over time, we're becoming more and more regulated. Sometimes those regulations seem like they're just there to make our lives hard. And I bitch and moan about Australian regulations, I know. But some of it is about protectionism and about preventing people who are not part of the club join the club. But a lot of it is because something has gone very badly wrong and the regulations have been put in place to minimize the chance of that happening again. Okay, there's another question. I want to use Shelly 4 Pro, but I don't know all products. Shelly is good and safety. So Shelly products, so the Shelly is a device that, or a range of devices, kind of in direct competition to the Sonoff. It's a power control device that you put in series with a load, and it controls the load. It's got Wi-Fi, and they have a range of products just like Sonoff, including devices they're equivalent to a Sonoff Basic. They've got DIN rail mounted devices equivalent to a Sonoff 4-channel Pro and other variations. And I have a number of Shelly devices, and I've never actually done a video about Shelly. So it's not because I don't like them. There is no reason that I have not shown them. They make really good quality devices. They have some very clever engineers that have done an excellent job. They are designed so that they can be flashed. They expose like a programming interface, which is fantastic. You can plug in a programmer and put Tasmota on them in general. I'm not sure if there are any models that you can't do it to. I think Tasmota runs on all Shelly models. They make good stuff. I really should feature those on videos. It's just one of those things where I haven't got to it. I have in a box just not far down here, I've got a whole box of stuff dedicated to Shelly, and I've got a whole lot of their different devices. And I've actually had I've had conversations with people at Shelly. They're good people. So some people might be wondering, hey, does John not like Shelly devices because he never talks about them? That's not the case at all. Shelly devices seem to me to be very well engineered. They're really nice. I like them. I just haven't featured them. Now, I've just noticed something popped up in the live chat. What is going on here? Aaron has just donated a super chat, which is very generous. Thanks, Aaron. And said, moderation budget for idiot in the stream. Okay. Yes, so I did notice that there was some weird stuff going on further down in the stream that I hadn't got to. I kind of accidentally scrolled to the end and I saw a whole lot of messages that had been deleted. So it looks like Guru of Nothing has been very actively moderating for me. So thanks, Grant. I really appreciate that. And whoever Dan Nicholson is, knock it the hell off. Stop it, please. sorry, Dan Nicholson has been timed out. I didn't actually see even what was said, because there are a whole lot of messages now that are just deleted. But I trust Grant's judgment on that and Aaron's, so thank you for taking care of that. Alright, so I'm going to have to look up what main ring, or what ring main is all about. So the ring main is looping around the GPO to GPO, and the last one is taken back to the switchboard and joined to the other one protected by a 32 amp HRC fuse. Alright, that's interesting. So it's to allow data over mains to send control signals. Alright. That is why I was confused earlier, because I haven't come across that. You know, the idea of taking power from your switchboard, looping it to power points, and then bringing it back to the switchboard. And that would never have occurred to me. No, what I was talking about in terms of looping power around, the standard way of doing it in Australia is if you have a power circuit for a couple of rooms, what you do is you take power from the switchboard through the circuit breaker, obviously. From there it goes to the nearest power point, and from that power point, or GPO, or whatever you want to call it, it basically daisy chains around to the next one, and then it might go around a few, like around a couple of rooms worth of power points on one circuit breaker. But when it gets to the last one, it doesn't come back to the switchboard. It just ends. It's essentially, you can think of it conceptually as being a long piece of wire, active and neutral, with power points at intervals along it. It doesn't come back to the start. So that is what I'm suggesting as still the best way to wire power points, rather than wiring each power point individually back to the circuit breaker. Now, what I'm going to do is, where is Aaron? I need to make Aaron a moderator, I think. Doesn't look like I can do that right now in the chat. Oh, I can. Add moderator. Let's see if I can do this. Aaron, you are now a moderator. You can stomp the ban hammer anytime you want to. And Dodgy was already a moderator. So yeah, Dodgy has been a moderator or an administrator on the SuperHouse forum for quite a while, and he's also an administrator on the Discord. So I definitely trust his judgment on whatever those rubbish messages were. So, all right. Oh, this is interesting. Okay, so Anstis Limited said, ring mains share the current load on each leg of the ring, thus allowing you to use smaller gauge of wire 2.5mm rather than 4mm. Problem is, if there is a break in the ring, you can overload the cable. Yeah. So if you've got a main ring, as was just described earlier, you could have current flowing out both legs of the ring to the load, which means that you're only getting half the current on each side. But that's assuming that you don't have more resistance on one side than the other, so it's likely there would be an imbalance. Yeah, it doesn't sound like a great idea to me. Let me, hang on, I've just noticed something weird. What's going, yeah. Alright. Yeah, so Aaron said, okay, cool, like a radial essentially then. Yeah, I think the probably, I don't know what the terminology is for it, but the way I'm describing the standard PowerPoint wiring in Australia is like radial, so it's a single line that goes out from the switchboard, but with multiple drops on it. So it's kind of like multi-drop radial instead of a single radial like I do with my lights. All right. Let's see. Oh, Andy said the Clipsal CBus protocol had a Java implementation, and you could just grab their Java jar and class files and use them in your own application. That's interesting. Yeah. So. Oh, I just saw the thing where Aaron said he's happy to be a moderator. Too late. You already are. And okay, trying to catch up here on chat. Okay, I think I'm kind of near the end, and I probably had to skip across a whole bunch of things in order to get here. So Daryl said ring mains is used in the UK for larger current but difficult to maintain. Yeah, it does sound like a scheme that's kind of interesting. It might have some little advantages, but I don't know. It sounds to me like the potential problems are, they far outweigh the advantages of a mains ring type. Is it mains ring or ring mains type arrangement? All right. Okay, I think I'm nearly caught up. Hopefully I didn't miss anything too important in the chat. Kerry B said, is that yellow device on the table a robotic arm? Almost. Let's see. Just looking at the preview of the video so I can see what you see. That is a water cannon, which I've actually shown on previous live streams. I've moved it around. I'm not going to go into that in great detail now because I've shown it before. And I'm sure that I will show it more in the future. There is an updated version of the mechanicals for that, which has just been fabricated by my brother-in-law, who runs a CNC manufacturing business for our mutual client, which is T-Rex water trucks. They do trucks that are used for watering of nature strips and dust suppression in mines and road construction and different things like that. So it's a water cannon that is used for mounting up on the top of a truck. It connects to a big pump and it sprays water out wherever you direct it. What would be really cool would be if I set up some kind of an online control system so I could let people on the live stream actually take control of it. Maybe I'll do that in the future. All right, but yeah, I'm not going to chase that squirrel right now because I've talked about it in the past. Now, oh yeah, this is a good point. Jason Lewis said, I thought ring main was used to save copper. After World War II, copper was in short supply and it meant you could wire a room with less wire. Yeah, perhaps it would have that benefit because you've got two smaller wires instead of one heavier wire. You could probably use the same wire as you do for lighting circuits. So lighting circuits typically are a lower current circuit than a power circuit going to GPOs, and running the same copper wire for lighting circuit, for one wire for a lighting circuit and two wires in the ring arrangement for a main circuit. Maybe that would save on copper and cost. Okay, Daryl said, I think this must be something I missed in the chat. Sorry, Daryl. Said, one idea I raised earlier was sending data over the mains cable. What are your thoughts on that? All right, so what this is talking about is instead of running separate wiring for control or using Wi-Fi for control, running data over the mains cable. And this is the scheme that was used. It's called power line signaling. And this is the scheme that was used by systems like X10 early on. In fact, when fairly early when I was playing around with home automation a long time ago. I used a bit of X10 gear, and the way that worked is that it uses the mains cable, which goes from your switchboard or wherever to your device, to supply power to the device and also to carry data over that same wire. And there were a couple of problems with X10. I mean, there are better ways you can do it now. X10 is very old. I don't know when it was designed. I think it was like 1970s technology. It was very low data rate. I don't think the original X10 protocol didn't have any acknowledgement. So, I mean, I'm talking now about problems that are historical. They don't necessarily apply now, but this is just the background to it. So what would happen is your control device, and there was a device called a firecracker, which was really popular, and what you would do is plug that device into a power point in your house, and I think it had a serial interface on it, and what you could do is send commands through the serial port into the firecracker plugged into the power point, and it would effectively broadcast those commands through the mains wiring in your house, and any device that was plugged into that same circuit would be able to pick up the signal. But the original protocol was only single directional. You would have a single point of broadcast, and then you would have multiple devices that would pick up those signals. So what you would do is you would set an address. There were typically a couple of selection dials on the back of the device, and you would set a particular device might be address 27, so you would set the switches on the back of it to make this device address 27. You'd send a command that says turn on device 27. All devices would receive it, but only device 27, or you could have multiple devices on that same address, which gives you a crude way of ganging things together. They would then receive that signal and then turn on or turn off. But there was no feedback, so you wouldn't actually know. Your automation system had no way of determining whether the device had received the message and acted on it. So one of the things that was quite common is you just send the command multiple times and hope it got through. And so it was very limited. And also very slow. There was a fair bit of lag. I think from memory, this is so many years since I've looked at it, but I think from memory, the way X10 used to work was that it would do its modulation synchronized to the frequency of the AC mains. So either 50 Hertz or 60 Hertz. I think it's 60 Hertz in the US, 50 Hertz in Australia. I can't remember. Something like that. Which means that if you are doing your bitstream transitions synchronized to the, say, 50 Hertz AC frequency, you're dealing with a very small number of bits per second of throughput. So if you do, like, not looking at the actual waveform, but just thinking of it in a really simplistic way, if you've got a 50 Hertz AC signal and you're doing transitions on the zero crossing, then you can transfer 50 bits per second. I mean, I can't remember how the encoding worked, but it's in the order of tens of bits per second of data that you're transferring. So to send a message, which was an address and a command, like a couple of bytes of data, it might take a second or a couple of seconds to send a little bit of data. So there was noticeable delay on X10 devices. You'd send a command, and then 2 seconds later your light would turn on, and it was pretty horrible. These days, of course, we can do a lot better than that. There are Ethernet over power solutions where you can get really good data, like decent data rates through mains cable, passing Ethernet over that mains cable. And so by using newer encoding methods and better technology, we could be passing data over the mains cable. There are some problems with it. I'm wondering where to begin with this. I don't think this is a rabbit hole that I really want to dive into discussing right now. It's an interesting topic, but for me, I think the biggest problem is that what it does is tightly couple the control system to the mains system, which simplifies things in some ways because it means you only need the mains cable. You don't need any other twisted pair cable or anything else like that. But what it means is that all of your devices are suddenly at mains voltage. I think there are situations where it can be useful. I don't know, I'm going around and around in my head how to respond to this question, and I'm not sure I have a very clear answer. To me, it has never felt like a particularly good solution because the benefits that it has, like reducing the cabling and allowing you to do things with just the mains cable, are not enough to overcome the problems of things like your logic and control electronics is now all has to be part of a mains device with the associated certification and risks and lack of ability to work on it because it's all part of that device. The difference between I just don't feel comfortable working with mains as well is one thing it comes down to. So I've been electrocuted by 240 volt mains. I think it's 7 times over the years. Starting from when I was quite young, like in primary school, I tried to wire up some mains lighting in a cubby house in the back of the school, and I grabbed some stuff that had been left behind by an electrician and wired it up and screwed up, and the end of my finger here to this day, I don't have a fingerprint on this part of my index finger because it was burnt off by the arc when I grabbed a mains cable, and it burnt the end off my finger, which was not a great day. I think I must have been in about grade 4, grade 5 when I did that. And I've had a few other things go wrong over the years where I've been zapped by mains power, and amazingly I'm still alive to tell the tale. But what it has given me is I think a healthy fear of mains. More than a healthy respect, it's given me a healthy fear of mains. I don't want to do anything where I'm interacting directly with 240 volts. Like you've seen me do things on the workbench where I've done demos wiring up son-offs and those sorts of things. But even when I'm doing that, I'm quite paranoid about it. I will have the cable, like the mains cable that comes down is just a cable that I've cut the end off so I can expose active and neutral and earth. And then I wire that up to the son-off and demonstrate how it works. But while I'm doing those demos for the video, I've got that cable plugged into a PowerPoint, and once I plug it in, I keep my hands well away from it. I don't go near it, and before I do anything with it, I turn it off at the PowerPoint and unplug it. I will never stick a screwdriver in there and play around with a son-off on the bench with mains power while it's still plugged into the wall, because I want to keep my fingers and I want to keep my heart beating. I leave that stuff to James just said, that's why John uses RFID instead of fingerprint scanners. Yeah, the funny thing is that fingerprint scanners actually work fine with this finger because the scar tissue over the end has characteristics as well. So I can unlock my phone. I think it is. Let's see. Yeah, I just unlocked my phone by putting my burnt finger onto the fingerprint sensor, and it worked fine. And so I can train a fingerprint sensor to work with it, and there is still fingerprint around half of the end of my finger. It's basically this half of the finger that got burnt off, but I can train a fingerprint reader and it works just fine. The scar is probably unique enough. All right. Oh, and Dodgy said, I'm not alone. A healthy fear is a good thing. Yes. Yeah, so Aaron said, I'm just thinking some sort of addressable protocol so each power socket on the ring or radial could be addressed and switched essentially. I'm not sure if it's possible. Yeah. So power line signaling is something that might be useful in the case of trying to control GPOs to avoid the whole Wi-Fi dependence thing. Now, this has just raised another squirrel in my mind. I'll mention it and then ignore it and come back to Aaron's point. The one thing that I have been struggling with for a while is how to do control within the switchboard, so for the relays. And one thing that if you take something like a Sonoff 4-channel Pro or a Shelly Pro, which they have an equivalent 4-channel, and you stick a few of them in a row on a DIN rail in a switchboard, you have them all within this little space. They're within a metal box, all close together, and you still use Wi-Fi to control them. And to me, that seems wrong. In that situation, I much prefer the way that CBus does it, with the CBus cable with the multi-drop cable. So you use screw terminals and you connect the pink cable, loop it around from device to device. Each device has its own address, and then you can control those devices. That makes so much more sense to me than having a whole bunch of devices all jammed together on a DIN rail and then addressing them by Wi-Fi using an access point that's probably like a meter away. It's stupid. Use a bit of wire. But we can't do that with the Sonoff 4-channel Pro or the Shelly 4-channel Pro. Now, I'm going to let that squirrel run off into the forest and ignore it. Get back to Aaron's point, which is addressable protocol going to each power point on the radial. So the reason I was thinking about that 4-channel Sonoff issue in the switchboard is that conceptually it's similar, and perhaps if the Sonoff supported some kind of power line signaling, that would solve the problem inside the switchboard, because we could do the signaling over the active feed that goes into each of the modules in the switchboard, and it would also solve this problem of control of distributed devices. If you've got smart GPOs distributed around a house, you give each one an address, they are all connected onto a common radial, like on the same main circuit, so they're on the same bit of wire effectively, and you want to be able to send a command that says PowerPoint 27 turn on, then having some kind of an addressable system that runs over the power line might be really sensible in that situation. So I have just gone back on what I said half an hour ago about, well, 20 minutes ago, about power line signaling not being a great thing. Perhaps in that situation, power line signaling is a useful solution. So that we don't have to run a control cable to each GPO because they're spread around a big area, and we don't have to rely on some form of wireless like Wi-Fi or whatever to control each of those GPOs. Well, Aaron, maybe you found that edge case where power line signaling is the right solution to the problem. And this largely comes down to my philosophy of there being no one perfect solution for everything. You have to look at the circumstances and figure out how you're going to solve the problem right here and right now, not in some different scenario. Okay. back to the chat. Let's see if I can catch up again because it's got away from me. Oh, incognito. Yes, this is a very good point. Also, make sure there are no big capacitors in the circuit either, or that can surprise you even after unplugging. This is in relation to my comment about not wanting to work on mains equipment until it had been unplugged. Yeah, power supplies often have big capacitors in them, and the no neutral systems in particular typically have a capacitor in them that is charged up to allow the device to coast through periods where it's not taking power off the circuit. And you can unplug things from the power and there will still be dangerous or potentially lethal voltages or amounts of power within the device, even when it's totally unplugged, disconnected from everything. The classic for that used to be old TVs, because old style TVs had very big capacitors in them. They generated very high voltages internally in order to run the coils to deflect the electron beam. So in the old style CRT, not LCDs, there were thousands and thousands of volts generated to put across the plates and the coils to move the little electron beam around to paint the phosphor on the inside of the screen and make the image that you see. And what could happen is you'd unplug, the TV would need repair, you'd unplug it from the wall, take the back off, and it might seem like it's perfectly safe, but in fact there can be thousands of volts still sitting across the capacitors inside it. If you touch it, boom, you got a problem. So yes, that is a very good point by Incognito3. Don't assume that because something is unplugged that it is safe. Alright. Oh, Dodgy just said, this sounds not good. One of my thumbs stopped working recently. Thought I was going to need reprogram, but it descarred and started working again. That doesn't sound good. Well, I'm glad it's working again, but it sounds like Dodgy, you might have a problem with the thumb. I don't like that. Mako said, I once touched the inside of a switch on an AT power supply on an old PC, and those carry the live wires to the switch instead of just signal wires from an ATX switch. Yeah. Just as a... and then he said, I mean, I got shocked. Yes. That is something that you see on 3D printers a bit as well. I was a little bit stunned when there was a particular 3D printer kit that I built a few years ago. What was it? It was a Mendelmax. That's right, the Mendelmax kit. Came with a mains power supply that is put into the chassis, and then there is a mains switch on the back. And the way the kit works is you put the power socket into the back of the chassis and then use some cables that go from the back of the power socket to the main switch and from the main switch to the power supply. And in the original kit, all of the terminals on the power supply were exposed and the switch was just directly switching mains. But it's an open frame 3D printer. So there was a cover over the top part, but the bottom of the frame is totally open. So you could have a situation where you have mains plugged in and you pick up the printer. If your hands are underneath it, you could be directly contacting unswitched mains. Not good. And those old style PC power supplies did something similar, where they would bring the mains to the switch, and the mechanical switch on the outside of the case was actually switching the 240 volts. And modern PC power supplies are much safer because the power switch is just a logic input. You just short it together. Essentially, it's shorting a digital input to ground, and it by logic ground, not mains ground, and it would and it turns on. It's just a logic control. There were some suggestions here. Hang on. Mike O'Connor. Hey, Mike. It's good to see you on the stream. Said use a PLC with AC switching and Modbus Ethernet or serial. There are cheap PLCs and you do not even need to write code in the PLC. Yeah, that's a really interesting suggestion as well. PLCs are something that I really haven't addressed on any of my videos. That's a PLC, or a programmable logic controller, is the way that industrial control systems have traditionally been done, and the normal way of programming a PLC is with a method called ladder logic. It's something that people that do industrial control are very familiar with, and for anyone that's outside of the industrial control field, they probably haven't even heard of them. Like if you said to a typical programmer that you were doing something using ladder logic, they would have no idea what you're talking about. But in the industrial automation space, this is the usual way things are done. It's interesting that there is such a so much fragmentation, I suppose, like a silo, isolation. There's a total lack of knowledge of the way typical industrial automation is done outside of that field. And it's not something that I really know anything about either. I mean, I know what a PLC is, I know what ladder logic is, I've had some passing exposure to it, but I don't use any PLCs in my home automation system, and yeah, I don't really have the experience with it to be able to say anything sensible about it. I'd leave that to the experts like Mike. So for those of you who don't know, Mike O'Connor in the chat is a very clever guy who I've known for many years, who does really cool industrial control stuff. He has done many conference talks about it, so I don't think he'll mind me mentioning it publicly. Hopefully I'm not revealing anything that I shouldn't. But Mike does things like build very large robots that are used for wool processing, for doing things like taking large bales of wool and moving them around and doing interesting things. So he does some large-scale robotics and industrial automation sort of stuff that is used for farming type applications. So Mike, hopefully I didn't give away too much there, but yeah, Mike has done talks at the Open Hardware Miniconf a couple of times and other places about his cool project, so hopefully that's all okay. All right. What else is there? What? How can I have got to 2 hours already? This is ridiculous. I'm going to wrap it up soon, but I'm just going to catch up on things in the chat. Andrew said, just use the Big Clive method of discharging capacitors with a thumb. All right. Let's not do that, please. Yeah. Well, I'm thinking of a story that I could tell, but I won't. Oh, yes, I will. Stuff it. This is just a silly thing, talking about discharging capacitors. Back when I was in school, so I think I've mentioned before that I mentioned this on Discord, some of my very first electronics work, my very first soldering, the reason that I got into soldering back when my age could still be measured with a single digit, was for model trains and wiring, doing things like soldering wires onto tracks and for controls for HO scale at the time model trains, and then I started doing a lot of N scale stuff later. I got bigger and the trains got smaller, and I've got sub-stories within stories here. I'll try to avoid going down them. The upshot was, part of the control system for for the trains that I had was a device that was designed by actually the guy who got me into electronics in the first place, a guy called Andrew Sparks. And he lived in a bungalow at the back of my parents' house when I was very little. My parents separated when I think I was 7 years old when they separated, so I was quite young. And back around that time, Andrew Sparks was living in the bungalow at the back of our house, and I used to go out and see what he was up to. And he was the one that really got me intrigued by electronics when I was around the age of 6 or 7. And so he built a point controller for my my trains, and so I had a permanent model train set up on a large piece of board. And what he did was got a piece of aluminium and drew the layout of the tracks on the aluminium with the positions of all of the points, and then he drilled holes and put 2 buttons next to each of the points. So press one button and the switch, and when I say switch I mean on the train tracks would flick one way and press the other button and the tracks would flick the other way. And this was done using a capacitor. So this is getting back to the capacitor point of the story. What he did was get a huge capacitor, I don't know where he got it from, but it was enormous, wired it up to a power supply so that when you pressed one of the buttons on the control panel, it would discharge the capacitor through the solenoid for that railroad switch, and it would flick the switch into the different direction. And so I had this control system with this big capacitor in it, and every time you press the button it would go bang and flick the switch over. It was probably overkill, but that's just the way he did it. Years and years later, when I was in high school, I took that same capacitor and I put a couple of long bits of wire on it, and I put the capacitor inside my pocket with the wire coming down inside my sleeve, and I had a couple of band-aids, so a band-aid on each finger, the wire coming up the inside of the finger, so there was a bare contact on the 2 fingers. And I had a little plug pack so I could charge up the capacitor, and had it set up so that I could charge it and unplug and then walk away and have the 2 live connections on my fingers. And then I could do things like brush up against something metal and put my hands on it, and it would short circuit across the contacts, and there'd be a big bang and an arc, and everybody would jump and go, "What the hell was that?" And I'd go, "I don't know, what was that?" And it amused me for about a day, freaking people out and leaving little burn marks on metal things around the school. Okay, I better stop that story. So, all right. I'm gonna just try to get through the last few things on the chat without without dragging this out too much. So, A-Tech Guy asked, does the sign-off give reliable on-off state condition back to the app when it is triggered from the device and not the app? Yeah, excellent question. Short answer is yes. So what that's getting at is the idea that you have a sign-off or a Shelly or whatever that is controlling your load, and it has local control, so it's got a button, and you can also control it through the home automation system, so you can send a command to it to tell it on or off. Now, if your home automation system is tracking the state of all of the devices in your house, it needs to know if something has been turned on or off. If you control it through the home automation system, then of course it knows because you've given it the command directly. But if the end device, like the Sonoff or the Shelly, has its own local control, and you walk up to it and you press the button or flick the switch and control the device locally, does the home automation system know that that has happened? The short answer is yes, because yes, but not necessarily. You can certainly set your system up so that it does, and I have. The way it works is dependent on the software that is running on the device. Now with my Sonoffs, I run Tasmoda on them, and there are other alternative firmwares as well. So I blow away the eWearLink firmware that comes on it and I just put on Tasmoda. There are some configuration options in Tasmoda related to doing things like status reporting. You can you can set it up with an MQTT broker so that anytime there is a state change on the end device, it publishes back to the MQTT broker and says this action has just happened. If you then set your home automation system up to be aware of those messages in MQTT, it can update its internal state. So what you have is the home automation system can send a command to the device and it changes state, and then the automation system knows the state has changed. Or you can go to the device and control it directly. It will change its state. It will publish that state change back to MQTT, and your home automation system can be aware of that and see, oh, that device has changed state, and then update its own little internal reference. And that allows you to do things like have toggle switches in your home automation interface that update dynamically even when you control the device at the endpoint. Okay. Yeah, so Andy said, the real problem is many appliances need more user interaction than just turning them on at a GPO. Focusing so much effort on GPO control ultimately falls short of what is needed. Absolutely correct. And he goes on to say, appliance manufacturers need to provide control interfaces either wired or wireless. Yes, Andy is 100% correct there. So everything I've been focusing on so far with this discussion of GPOs is just turning on the power. And this really comes back to examples. Okay, I'll use the TV as an example. I was saying earlier that with something like a TV, what you normally do is you will put the TV in place, you'll plug it into a GPO, you'll turn the GPO on, so the power is constantly available. Your interaction with the device is then through the device's own user interface. And so being able to turn on and off power from the power point is not that useful in most situations. I mean, there are situations like desk lamps, for example, where it might be useful. But for many devices, they have much more complex interactions, and the user interface is dependent on the device. It's not just simple power on-off. And I do like that so many manufacturers are now exposing APIs on their devices. And at the moment, this does seem to be a little bit of a differentiation between what you would consider a premium brand or a premium device and the devices that are built down to a price. Now, for example, the main TV in the lounge room in my house is a Samsung TV, and Samsung expose an API that allows home automation systems to talk to it. So there is a Samsung plugin for Home Assistant and for OpenHAB, and I think there's even a Samsung plugin for Node-RED, I think. I can't remember. But basically they expose an API or application programming interface that allows you to send commands over the network and control the device. You can turn it on, turn it off, change channel, change the volume, all of those sorts of things. And Andy is absolutely correct that controlling power is not solving the problem. It is only a small piece of the solution. And having device manufacturers expose some way of controlling their devices is a much broader solution. So that's really what we want to have ultimately. All right. Mike asked, does anyone know of a barometric sensor which transmits via 433? So that's 433 megahertz, a regular RF transmission. I actually don't know of one. Perhaps someone can suggest one. Given the time, I am going to be ending this live stream any moment now, so it may be too late for an answer for Mike for this, but if you do have a solution, if you've got a suggestion for a barometric sensor which transmits just regularly on 433 megahertz, maybe jump on the forum or the Discord and make a suggestion, because this chat will probably go away as soon as I end the live stream. Alright. Dodgy said, the time we nearly electrocuted the homemate was with high voltage DC. Got the spark jumping about 5 feet before it stopped earthing back to the car. Blew him off his feet. Wow. That sounds like a story you need to tell. Maybe tell that story on video or in the Discord or somewhere. Yeah, and Mako points out Chinese PSUs with just the metal casing have open terminals too. Yeah, and that's typically the type of power supply that is used in 3D printers. All right. A tech guy just followed up and said, thank you for the answer. Will it also remember its last state on a power failure? Once again, that depends on the firmware, but the short answer is yes. In the case of a Sonoff running Tasmoda, there is an option that you can configure the power up state. It's like a computer. On a computer, you can, in the BIOS, typically say, do you want its power on behavior to be off, which means you plug in power, turn on the power point, and the computer stays off. Do you want it to be on, so you plug in power and it turns on every time? Or do you want it to be last state? So if the computer was off when the power died, stay off. If the computer was on when the power died, turn on. Those sorts of options you can do through Tasmoda as well. So you can set the state of the device, and then the issue is, how does your home automation system know that the Sonoff has is on, and it has turned on in an on state or an off state? So that can be solved by the Sonoff reporting its status back by MQTT. So I won't go into the details of all of that now, but short version is yes, that can be done. All right. I am going to have to call it, partly because my brother-in-law is going to be coming over soon and dropping off some stuff. So the same guy that did all the CNC machining and built that. And I need to be off the live stream before he gets here. And I told him I was live streaming until 12, so he could be here anytime. All right. One final thing. Aaron said, but with the capability now with high bandwidth over power line, couldn't the solution we've been discussing be used for controlling other things? Yes, it could. So power line control is it's a method that kind of failed because it was tried too soon, I think. If you were coming up with a standard now for power line control, you could do a much better job than was done back in the 70s when X10 was defined. And we could have full bidirectional links. I mean, you can run Ethernet over power line, so we know we can get the data rate through, we can do all of the error correction, we can do acknowledgements, all of that sort of thing. But let's not bite off the job of designing a new power line control protocol right now. I have far too many squirrels running in far too many directions to be able to chase that at the moment. Thank you very much, everyone, for coming along. This has been, well, I've kind of enjoyed talking about this. It's an interesting subject. I thought maybe I would talk about this for the first 10-15 minutes of the stream, and then we get on to other things, and 2 hours later, I'm still kind of talking about the original topic. One final thing. There was an excellent suggestion that Perhaps what I could do in order to have a little bit more focus on these live streams is to take topic suggestions before the live stream and not just react totally to chat. Now that's not quite the way the suggestion was worded. That's the way I'm wording it. The suggestion was in a much nicer way than that. But what the suggestion is, and I think what I'm going to do is I'm going to get input from patrons and GitHub sponsors, supporters, and maybe get them to submit some questions or topics or something, and that way I can think about them before the live stream and come into them with a little bit of a clue of what I'm going to talk about, instead of just hit go live and then figure it out as I go. So sometime between now and the next live stream, what I'll do is send out an update to my patrons and my GitHub sponsors, supporters, and ask for things that they would like specifically discussed on live streams, and then I can address those things. So, oh yes, and Daryl said, I think you need a moderator following the chat and highlighting questions to you. Yes, I know. I need a producer. I don't know, maybe I'll get there. One of these days, I'll probably get either my son or my daughter sitting on the other computer and being a moderator. But in the meantime, you got what you got. So, thank you very much. Have a fantastic weekend, what's left of it, and week. And I will see you in the next live stream. And hopefully before the next live stream, the next actual proper prepared video, which should be part 4 of the air quality sensor mini-series. I also have another video which I'll stick up on the vlog very soon, which is building feeders for the pick and place machine, because I've just been building a couple and I've been filming the process with hints and tips along the way. That's probably not of interest to most people, but for people that are wanting to build a feeder, it could be useful. So I'm going to post that as a vlog at some point too. Thank you very much, and good night.